Hi there. In this video, we're going to continue our study of section 3.1. If you haven't watched the live Zoom class, I encourage you to do that because I'm just going to recap some of what we talked about in the live Zoom class. So you can go to our Canvas homepage and watch the recording. So we have to put a quadratic function. So when you have a quadratic function, it looks like f of x equals ax squared plus bx plus c. And we want to put it in the form a times the quantity x minus h squared plus k, because then we can get the vertex. So to put a quadratic function from ax squared plus bx plus c into the vertex form, then we need to complete the square. So here we say we complete the square. So it will be a good thing to go back to section, it was in chapter 1 where we did completing the square. We did solving equations by completing the square and the quadratic formula, but the process of completing the square will be the same. So once we have it in vertex form, the quadratic function, we can identify the vertex. So the vertex is the coordinate point hk. And so as we talked about in class, is whatever makes this 0. So x minus h is 0 when x is equal to h. So that's the x value of the vertex, and the y value of the vertex stays with whatever sign you have there. If a is greater than 0, so if this is positive, the coefficient in front of the x squared is positive, then the graph opens upward. And this is what I call a happy face parabola. And if a is less than 0, so negative, so if the coefficient in front of your x squared is negative, the graph opens downward. So, and this is what I call a sad face parabola. So let's look at some examples. The graph of this is already in vertex form, so I can identify the vertex and which way it opens. So the parabola opens which way? Upward or downward? Do we have a happy face or a sad face? Well, the coefficient, this is our a is equal to 3, which is greater than 0. It's positive. So the parabola is going to open up with vertex. The vertex is going to be whatever makes that inside 0. So x minus 2 is 0 when x is 2. So at 2 comma negative 5. The y value, the k, we keep the sign. And let's move on to the next one. The graph of f of x equals negative 2x plus 1 squared minus 3 is a parabola that opens. Now, since my a here is negative 2, which is negative, so less than 0, the parabola opens downward. And the vertex is negative 1, negative 3. Now, when you have the vertex, you only need 2 other points. And as we talked about in class, you can find the y-intercept of the parabola and then plot that and then do the mirror image. So let's try a few examples here. Find the vertex of the following quadratic functions and determine whether the function has a maximum or a minimum value. And just in class, we talked about a maximum or a minimum occurs at the vertex, right? In this case, you have a parabola here that opens up. So looking here at my happy face, notice that this is going to have a minimum value. Whereas when a parabola opens downward, you're going to have a maximum value. So that's what we're looking at, and it's going to occur at the vertex. So to determine whether it has a maximum or a minimum, we're really looking, does it open upwards or does it open downwards? So when you look at A here, is this going to have a maximum or a minimum? Well, the coefficient here is a 1, so my A is 1, which is greater than 0, so this parabola opens up, which means that we have what sort of a thing? A maximum minimum. So if it opens up, that means it looks like a happy face, so we're going to have a minimum. We have a minimum at the vertex. For all of them, the maximum min occurs at the vertex. It's just whether we have a maximum min. For this one opens, it's a negative. A is negative, so it's going to open down, which means we have a, we without an H. We have a max. And this one is positive, so we're going to have a min. So that's just by looking at it, we can tell whether we're going to have a max or a min. Now let's do the work in finding them. So let me look at part A first. Okay, so we have part A here. So I want to put it in the vertex form. So that means I need to complete the square. Now to complete the square, I really only need the x squared term and the x term. So I'm going to rewrite this as x squared minus 6x. I'm going to leave myself some room and then the minus 4. So what do we do to complete the square? We take the b term, the minus 6 here, with sign and everything, and we divide it by 2. And I get -3. Now this -3, we square it. So -3 squared is 9. So that's what I add. When we had an equation back in chapter 1, we would add it to both sides, but this is not an equation, this is a function. So I don't have two sides. So I'm going to add it and then I'm going to subtract it as well. Because notice 9 minus 9 is 0, so we haven't changed the value of the problem. But now, with the reason of completing the square is because it gives me this trinomial, and I can factor that trinomial into a perfect square. And this factors two numbers that multiply to positive 9 and add up to -6, -3, and 3. So then this becomes x minus 3 quantity squared, and then my -9 minus 4 gives us -13. And so now I have put this in my vertex form. So I can tell that the vertex is going to be 3, -13. And we had said up here that this opens up, so we have a minimum value. So that means that the minimum value is y equals -13, and it occurs at x equals 3. And so that is our vertex, which gives us the minimum value. Now, if I wanted to graph this, I have the vertex and I need 2 more points. So the best thing to do, or at least what I find the best, is, let me erase some of this, is when we have it in the standard form here, find the y-intercept. So from here, find the y-intercept. So the y-intercept is when x is equal to 0, right? So then plug it in. So y is going to be f of 0, which is 0 squared minus 16, 0 minus 4. So I'm just going to get -4. So the y-intercept is the point x is 0, y is -4. And now I also have the vertex 3, -13. So I can plot the vertex, I can plot the y-intercept and do the mirror image of the y-intercept, and I will have my graph. So I already graphed it for us using my Desmos calculator. And so here it is. And so if you're plotting it by hand though, you will go to the vertex. So this is 3, -13. And notice that it is a minimum. Here's our y-intercept, 0, -4. And so to find your third point, you just go mirror image across the line of symmetry. Your line of symmetry is x equals 3. So if you draw a line here, see if I can do it without being crooked. It's hard to do it on the tablet. Okay, so this would be the line equals 3, which is the line of symmetry. Meaning, if you were to fold in half along this line, they will match up. And so notice that then my mirror image, this is 3, so this should be 3 as well. So this would be the point. So if this is 3, then this will be 6. So it'll be 6, -4. So I have my 3 points. Any 3 points determine a parabola. So I need the vertex and 2 more points. So for me, the easiest thing to do is find the vertex, find your y-intercept, and do the mirror image of your y-intercept. And that gives you the 3 points. Okay, let's try the next example. So the one that opens downward. So part B, f of x is -x squared plus 10x. So let me copy that and bring it down below. Okay, so in this one, we have a negative. So this, as we discussed above, this opens downward, which means we have a maximum at the vertex. So we need to find the vertex. Now, let me pause here. So if you're going to graph it, notice that this is y equals negative x squared plus 10x. So if you find the y-intercept, so you set x equal to 0, notice that if x is 0, you're going to get y equals 0. So that means that the y-intercept is the point 0, 0. So at least we have that. Now we need the vertex and then do the mirror image and we'll have a graph of our parabola. So let's put it in vertex form so that we can identify what the vertex is. So I'm going to have f of x equals negative x squared plus 10x. Now in completing the square, we have to have a 1 in front of the x squared. So a has to be a 1. Right now I have a negative 1, so I can't complete the square. So I have to do a little bit of math to make it look okay. So what I'm going to do is take that negative 1 that's there, and I'm just going to factor it out. So I'm going to have x squared then minus 10x. And now on the inside of the brackets, I can't complete the square because this is a 1. And so let's complete the square. So my negative 1 that I factored out is hanging out outside. This is x squared minus 10x, and we use our completing the square. So I'm going to take the minus 10 divided by 2. This means negative 5, and then we square that. Negative 5 squared is 25. So that's what we add to complete the square. But if I just add 25, I completely change the value of the function. So I need to subtract 25. 25 minus 25 is 0, so I haven't changed anything. And the whole idea of completing the square is so that then it gives us a trinomial that we can factor into a perfect square. Which perfect square? X minus 5 squared. Right? What two numbers multiply to positive 25 and add up to negative 10? Negative 5 and negative 5. The shortcut is whatever you get when you divide by 2, that's what's going to go in here. And that trick is really helpful when you have things that are not so pretty, like fractions. So, and I have my minus 25. Now let's get rid of the outside brackets by bringing negative 1 back in. So I'm going to have f of x is negative 1 times x minus 5 squared. So the negative just goes out front. And negative 1 times a negative 25 becomes positive 25. And so the vertex is, what's the vertex? So it'll be 5, 25. And it opens downward because there's a negative out front. And we already know from our work above that the y-intercept is 0, 0. So this is going to be a very narrow parabola. Notice that it goes, the x value is 5 and the y value is way up at 25. So this is going to be a little bit harder to draw. So I did it also on my Desmos online graphing calculator. So here it is. So it opens downward, and we have the vertex is up here, which is the maximum of the parabola. So this is the point 525. So that means that the maximum value is y equals 25, and it occurs at x equals 5. Now, the way I graph it, right, I plot my vertex, I plot my y-intercept, which was 0, 0, and then x equals 5 is our line of symmetry. So if I'm able to graph these, the line of symmetry, which is here, x equals 5, and with our y-intercept being at 0, 0, and our vertex being at 5, that means that this distance here is 5, and then, so from our line of symmetry, we have to go another 5. So that puts us, the mirror image point will be like 5 and then another 5 puts us at 10, 0. So to graph a parabola, find your vertex, find your line of your one other point. So I usually use the y-intercept and then a mirror image point. And so there we have our nice parabola. So once you have those 3 points, you can graph it following, I'm trying to connect them. And that is it. So we're able to find the maximum because this is a parabola that opens downward. So it has a maximum and we have our 2 points. All right, so let's go and try the next problem, which is part C. Where was it? Up here. So f of x equals 3x squared plus 2x minus 2. This one is going to be a little bit harder because now we're going to have to factor that 3 out, and this is going to become a fraction. So let's see what that looks like. Okay, so to complete the square on this one, again, notice that we have a 3 in front of the x squared, so we can't complete the square until that's a 1. So what we're going to do is, as we did in the previous one, we're going to factor out this number. So when I take out a 3, I'm going to have x squared plus, and this is where it gets tricky, right? In order to, since I've taken out a 3 from 2, I end up with 2/3 x, and then minus 2. Right, in order to complete the square, I only need the x squared term and the x term. So I don't need that -2, so we're going to put it out there. And so to check it, multiply it back in. 3 times x squared gives me 3x squared. 3 times 2/3 x, notice that then the 3's are going to cancel and we are left with 2x. So that's what I want. And then I left a gap here because we need to figure out what am I going to add to complete the square. So let's complete the square. I'm going to have f of x equals 3 times x squared plus 2/3 x. And so now I need to add and subtract stuff. And what is it that I add and subtract? Well, I take the coefficient of the x term, so my 2/3, and I divide it by 2. So 2/3 divided by 2. I'm going to write it as 2 over 1 because I have fractions here. So this is the same thing as saying 2/3. Instead of dividing by 2, we can multiply it by 1/2. And notice that now my 2's cancel and I'm left with 1/3. And now I square that. So 1/3 squared is 1/9. So this is what we add to complete the square. So I'm going to add 1/9. But again, if I'm adding something, I've completely changed the value. So I need to subtract the same thing. 1/9 minus 1/9 is 0, so I haven't changed the numerical value of my function. But now, this allows me to have a trinomial that factors into a perfect square, hence the name completing the square. So let's go down here. So I'm going to have f of x then is 3, and then the bracket, and now which perfect square? And then my -1/9 minus 2. I'm going to have minus 1/9. Oh, but that's still inside the bracket. So I'm going to leave the bracket there and then minus 2. So which perfect square do I have here? So this is a little bit harder to do because we have fractions, right? Because you're looking for what two numbers multiply to 1/9 and add up to 2/3. So this one is actually not too bad because you can say, oh, 1/3. But also remember what I said before, that whatever you get when you divide by 2, so here we divided by 2, whatever you get, that's what goes in here. So I can just say this is x plus 1/3. So this 1/3 is what goes inside the parentheses. And now we can simplify it. Bring the 3 back inside the brackets. So the 3 is going to get multiplied by the coefficient of this. So I'm going to have 3x plus 1/3 squared, right? Following the order of operations, be careful not to bring the 3 inside the parentheses, because order of operations tells us do parentheses first, then exponents, and then multiplication. So I can't bring this 3 in without doing that square. And then 3 times -1/9 is -1/3, and then minus 2. This 2 was not affected by that 3, right? The brackets ended here. So I don't need to multiply that 3 by the -2. And Let's simplify. Negative 1/3 minus 2, get a common denominator. So what's that? 6/3 minus 1/3 is negative 7/3. And now we have it in the form that gives us the vertex. So the vertex is negative 1/3, right, or whatever makes this 0. So negative 1/3 will make it 0. And this one stays as it is, negative 7/3. So that's the vertex. And this parabola opens which way? Upwards or downwards? The 3 is positive, so this opens upward. So that means you have a happy face parabola, which means you have a minimum. So the minimum value is y equals negative 7/3. Okay, so if you want to graph it now, you need 2 other points. So it will be the y-intercept and the mirror image of that. Okay, so I'll record another video on word problems, solving applications using quadratic functions.